Thank you very much for coming. I will explain that I don't normally talk about myself. I normally talk about other people. And so, for example, if you were here during Don's talk just a little earlier, he's one of the people I love to talk about because we go back a long way. We've done a lot of stuff together. I'll remind everybody that Linux is a registered trademark of Linus Torvalds. He wants everybody to use it for any legitimate purpose. However, to protect the trademark, we do ask that you go to the Linux Mark Institute and request a license to use it. It's free. And at the same time, we might even give you some legal advice about how to best use the term Linux in your particular trademark. Okay? So, who am I? For the people that don't know me, I started programming in 1969. My college undergraduate degree was half electrical engineering and half business. Seems like a strange degree. We called it commerce and engineering. But at that time, I also took a smattering of data processing courses. We didn't have computer science back then. We only had computer black magic. And there weren't too many schools who admitted to having computer science in their degree program. In fact, we'll learn later that we had no professional programmers back then. And I'll explain what professional programmers were a little bit later. I did a lot of work on various companies, large and small. I worked on nonprofits, had a wide variety of different jobs inside of her. But the thing that I'm proudest of is that I am pragmatic, which means I like to get the job done, okay? And I try and do it well. So before I started programming, in fact, shortly after I was born in Baltimore, Maryland in 1950, my father was a machinist, mechanic, trained in repair of airplanes. He could take a car engine apart, put it back together with no parts missing and no parts left over, without directions, okay? And he could basically do anything with wood or metal or anything like that. He also subscribed to a bunch of magazines we had back in those days. Popular Mechanics, Popular Science, Popular Electronics, right? Which he never did anything with the electronics except read them. He was very interested. And most of those magazines back in those days actually told you how to build things yourself. They weren't just advertisements for other companies saying how great they're going to be. My father also worked part-time in a toy store, which is wonderful for a child of, say, 8 to 16 years old, because you got to have model trains and stuff like that. You would help out at the toy store, carrying things up, but most importantly, assembling complex toys. Because while my father could take a car engine apart and put it back together with no directions, he hated reading directions, okay? He hated following directions. And so if anything had directions, he would hand it to me and say, put it together. And so I got used to following directions and assembling complex things and stuff like that, and I enjoyed doing it. About the time I was 9, I was introduced to a gentleman named Mr. Groom. He lived 2 houses up from us. He was an old man with white hair and a white beard, and if you knocked your wiffle ball into his backyard, you might as well kiss it goodbye. Because if you tried to pick it up and you got caught by Mr. Groom, well, you just never were seen again, okay? And everybody lived in terror of this person. And I had taken an old wind-up clock apart in my basement, the mantle clock. Of course, I couldn't put it back together. And before we moved, my parents said, "You have to take this to Mr. Groom." Mr. Groom. And I took my box of parts up to the door, and I rang the bell, and Mr. Groom came to the door, and I was sure I was going to be killed right on the spot. I said, "My parents wanted you to have this." "Oh, thank you." Close the door. A couple days later, I'd forgotten completely about this, right? "Mr. Groom wants to see you." Went to the door, rang the door. "Come inside. We're going to go down into the basement." Oh, the basement. We all know what happens in the basement, right? Goes down in the basement. It was a wonderland. He had wire recorders, which were previous to tape recorders that he had put together and gotten working. He had jukeboxes. You put the dime in to play a jukebox. He'd catch it in the coin slot on the other side to play a record. They were all 78s, playing. He had mechanical clocks. He had everything because everybody in the neighborhood brought their stuff to Mr. Groom. They knew they were not going to get it back. He was just going to make it work again. And I spent the best afternoon of my whole life down in his basement while he was patiently showing me all these things, including the clock I brought to him just a couple days ago as a basket case. So I learned a valuable lesson from this, that maybe the person you most fear is also the person that can teach you the most, okay? We moved shortly after that, never saw Mr. Groom again, but this kind of inspired me that when I got into high school, I took 3 years of electronics shop in high school. Now I'm going to take you back in time, because transistors had come out a few years before, but they really weren't that much into the industry or stuff like that. We were still working with vacuum tubes and capacitors and resistors, discrete components, stuff, and they were so expensive, you'd have to spend $1.25 back in those days to get a single transistor. Now you could fill up your car's gasoline tank for $3.50, okay? So a single transistor was 1/3 of a tank of gas. You can think of it that way, all right? And so, and everything was expensive. So what we would do is we would take apart old radios and TVs and stuff to get the resistors and the capacitors and the coils and stuff, and then we would design new circuits, but we would have to design them to use the components we had, which is harder, okay? But I loved it. I loved the class, and this got me started on my path to being an electrical engineer. I also, during that time, had some summer jobs. One summer job was as a Fuller brush salesman. Now, many of you don't remember or have never known about Fuller brush, but back in those days, there were these people who would go door to door selling you mops and brushes and cleaning you stuff and stuff like that. And they would show you the catalog, and then you would order from it, and then the next week they would come by and deliver it to your house. Well, this had been going on for a long time, but they were typically sold to large houses. And as supermarkets and stuff started to carry this stuff day to day, if you didn't see them every month, they would not get used to you coming around, and so they would stop buying from Fuller Brush. So I, as an 18-year-old kid, was given a route of buildings to go to try and sell it, and they say, "Oh, sorry, I bought that last week at the supermarket, but you come back next month and I'll give you an order." Well, I never got that route the next month. That was given to an older, more experienced Fuller Brush salesperson. So I basically lost money on my summer of trying to sell Fuller brushes. But fortunately, I also got to work at the Hog and Sheep Pavilion of the Maryland State Fair, and that pays some good money sweeping up, cleaning up after hogs and pigs. And I found out that hogs are the smartest domesticated animal and sheep are the dumbest. And there is a reason why in the Bible Christ is called the Good Shepherd, right? Because he's guiding all the miserable, stupid sheep in the world. All right, but in any case, I was accepted to Drexel Institute of Technology, which later became Drexel University, and I matriculated as an electrical engineer. And Drexel is a co-op school, which means you go to school part of the year and then you go and work part of the year. And I was lucky enough to become a co-op student at the Western Electric Company in Baltimore, Maryland, that made all of the wire and cable for the Bell telephone system. We made enough 22 gauge wire, which is very small, about the size of a human hair. We made enough of that wire to go to the moon and come back 7 times every day. Every day. And you take two of those wires, coat them with plastic and twist it, that made a twisted pair. Take 2 twisted pairs, twist them together, that made the C-drop cable, which goes from the telephone pole into your house. We made the coil in the coil telephones that you used to see. We made all of that wire cable. We made the cable that went underneath the ocean for what was known as long lines. That was coaxial cable. We made it all, okay? We had 4,000 people in that plant, most of whom were manufacturing people, but we had an engineering staff of about 500 there. And I was a co-op student at some of the most brilliant, as far as I knew, electrical engineers on the face of the planet, okay? And they came to me one time and they said, hey, we have this correspondence course in how to program an IBM 1130 computer in FORTRAN. Now, we had a conversation earlier about what type of FORTRAN. It was not FORTRAN 2, FORTRAN 4, FORTRAN 77, FORTRAN 90, High Performance FORTRAN, or any of the other ones. This was FORTRAN, spelled in all capital letters. And why would you need anything like an if-then-else statement? Because an arithmetic if statement was fine for everybody, okay? And I learned to program that by reading a book and practicing. I did have a couple of mentors who were there in a small little computer system. That, by the way, is the IBM 1130 that I did. It ran one program at a time. You linked the device drivers into the program itself, and then you did an initial program load of the program itself that was running inside of the computer. There was no operating system, okay? And I loved it. I loved doing it. And I did, every time I went back to Drexel, I did less and less electrical engineering and more programming until finally I switched my major over and it graduated. And I was almost electrocuted. 13,600 volts, 800 amps. I couldn't see anything of my arm from here down. It was all smoke and flames and stuff like that. That also helped me make the switch. Because what was going to happen to me? A paper cut? Okay? Get my fingers stuck in the keyboard? Okay, no. Never had that happen. So I went back to Drexel Engineering. At Drexel University, was doing the commerce and engineering with my data processing minor. And during that, I had my first course on compiler theory. Now, compiler theory, from my viewpoint, is hard to understand because it's the only time where you're not just adding together numbers or moving things around. You're actually doing a transaction. You're doing a transformation of a high-level language into the ones and zeros that the computer's going to understand. And this just throws a lot of data processing people for a loop, including me. We were using these two books by Aho and Ullman. Al Aho of Bell Labs, Jeffrey Ullman of Stanford University, and they had these two separate books that were phenomenally expensive that nobody could really understand. And then you'll see how this keeps coming back time after time. I almost flunked the compiler course, but I did make it through. And I also found an electrical engineering lab there that had these two computers in it. One was a PDP-8, and the other was a Link-8, which is they're both made by DEC, both relatively simple machines. The PDP-8 had no operating system of its own. You did programs right to the metal. And you couldn't use a high-level language. You didn't have enough room for this high-level language, so basically you had to program in assembly language. The PDP-8, if you had it today, you would say, this is like a RISC-V, only very primitive. Because the components, they were not integrated circuits, they were discrete components. And so to take these discrete components and hook them together into a processor was very expensive. That little machine would cost $50,000 in 1969, okay? It only had 4 kilobytes of 12-bit words as memory, all right? It had no I.O. devices other than the blazingly fast ASR 33 teletype, which you could use either as a console or you could read in paper tape or punch paper tape, okay? And so this is what you were doing. From the time I wrote a program to the time I actually got it to assemble, debug, and stuff like that was easy. Its simplest program was easily 5 or 6 hours of running paper tape, punching it out, reading it back in. The assembly was 3-pass. It was reading it 10 characters a second. Do the math. If your program is 3,000 characters, it takes 30 seconds to make 1 pass. 3 passes, it was horrible, but we loved it. And in the meantime, I said, hey, this is really cool. I'm going to start the Drexel Computer Club. So we started a computer club of a bunch of nerds sitting together and talking about computers. It was great. I had a professor at the time teaching me some type of programming languages. His name was Dr. McGinnis. He said, John, you're never going to be able to earn a living as a professional programmer. I'm still waiting to find out if he was right. I'm still alive. Maybe in the next year the whole thing will collapse. I don't know. So we have a good thing of what is a professional programmer versus an amateur? Don touched on this in his talk, but it wasn't enough to put me off. Because amateur programmers, a lot of times back in those days, were writing the code to solve their own problem. They were physicists, they were chemists, they were business people, they were electrical engineers, and they knew that these computers could help them solve their problem. And so they learned whatever they had to learn to be able to write the programs to solve their own problem. But then they would say, okay, I wrote this code, what am I going to do with it? Am I going to sell it? Well, let me tell you something. I've sold code for like 50 years. I can tell you it's hard work. You have to have documentation. You have to have advertising. You have to have people to support it. You have to have all this stuff. And these people say, that's not my job. I'm a physicist. I'm a chemist and stuff. So I'm not going to do that. So what did they do with it? They gave it away. They gave it away to organizations like Deakus for digital, or Share for IBM, or Mindstorm for Novell. They gave it away, and these organizations categorized it, put it into paper catalogs that you could buy for $15. Now remember, I said $5 is a lot of money. You had to pay $15 to get this paper catalog to come from Deakus, sent through the postal mail, that you would get, and you pour over it, looking at all the descriptions of the programs and what operating or what system it ran on, okay? And then you might say, oh, here's a really cool text editor that I could buy for only $5. So you send away your $5, a couple weeks later you get this paper tape in the mail, and you say, oh, $5, but that's still a lot of money. $5 could buy you 10 pitchers of beer. So now you have this battle within yourself, a text editor, which is really cool, or 5 pitchers of beer. But then, remember, copyright didn't come in to cover software until the 1980s, right? And you couldn't patent it either, right? So this was unpatentable free software. And, and it was, that's it. Go ahead and make copies of it. So I go to the school store, I buy some new paper tape, run it through my trusty, oops, what happened to it? It was there. My trusty ASR 33 teletype, make 10 copies, which would pay, and sell it to my roommates for $1 a copy. So then, I was like the original Red Hat. Okay? I was selling the service of finding the good text editor, making the copies, and giving it to them. And so I would make back my original $5 plus the $5 for the new paper tape, so I could go ahead and buy my 10 pitchers of beer. And I think you can see in what direction I would normally go. Now, professional programmers, and there were a few, they wrote code for other people. These people may never even use their own code, right? Do you think the Microsoft engineers sit around all the time making PowerPoint presentations? No. Do you think that they do spreadsheets? No. Okay? They don't do that. They don't use their own code. Users use the code. But they're professional programmers because they get paid money to do it. No passion, just money. So for me, programming was a game. It was like a puzzle. Nobody had to tell me that my program was good. I wrote it. I used it. I knew it was good, right? It was instant gratification, and there's only certain things in life you can get instant gratification, but we can't talk about that because this is a mixed audience here, okay? But it was great. And so I learned PP8 assembly language by reading a book that was given to me by a DEC salesman, because it also was $5. And I read that book and I practiced, and that's how I learned it. And then, believe it or not, and this really surprised everybody, surprised my family, it surprised me, surprised my professors, that I graduated from Drexel with high honors, because I'd gone from a 1.16 term average as an electrical engineer to a 4.0 as a commerce and engineering data processing minor. But with that, I then had to go out and find a job. So I printed off 500 resumes on paper. I typed up 300 cover letters on a manual typewriter, mailed them off, and from that I got 20 interviews, 5 second interviews. And out of that I got 3 job offers. And the last one, I got the honor, the privilege of turning down 2. But in one of those interviews, the second interviews, they asked me a crucial question. They said, "You taught yourself how to program an assembly language from reading a book?" "Yeah." "Do you think you could learn IBM assembly language?" I says, "I don't know. Do you have a book?" And that must have been really, strong coming from a recent graduate student, but they believed me. And between the time that I had that second interview and the time that I went up to accept the job, I'd found programming the IBM 360, 370 series in assembly language, and I'd read it. So lo and behold, the company I went to work for was Aetna Life and Casualty. And maybe none of you have heard of that company before, but at that time they were the largest multi-line insurance company in the world. At night, the whole building glowed because of the money flowing through it. Okay? And they were also the largest commercial user of IBM equipment in the world, which shows if you have adjectives around you, you can be the best of anything, right? Because we didn't know what China and Russia were doing, so, in the free world, and we didn't know what the military and the government were doing, so commercial, we were the largest commercial. And we automatically ordered 2 of everything that IBM announced. Didn't make a difference if it was a mainframe, a disk drive, a tape drive, whatever. They announced it, we ordered 2. One went up to our research division to figure out how we were going to use it. The other went down to the shop floor because we're going to start using it right away. We had 500,000 magnetic tapes in our tape library on site, and another 100,000 in a tape library in Idaho in a salt mine for long-term storage. And I only programmed in IBM assembler. Now, by this time, I studied many of the different languages. I studied Algol, COBOL, FORTRAN, Snowball, you name it, Lisp, you name it. I studied them all. But they wanted me to write an assembly, and they didn't want me to write new programs. They wanted me to take programs that people had written in other languages and make those programs run faster. And my boss said to me, if you can't make them run twice as fast, don't even waste your time on them. And so I would take programs that would run in 15 hours, make them run in 5 hours. I'd take programs that would run in one program, and this is going to be hard for you to believe, I understand that. It ran in 10.5 hours. I made it run in 3 minutes. Same language, same operating system, same hardware, no changes, just the programming of it. And I reduced the line of code from a huge amount of code down to something that was relatively small, using something simple called recursive reentrant programming. So this is what I did. And I would also help debug errors in compilers, because the COBOL programmer would come to me with tears in their eyes saying, I don't understand what's going on, I don't see the error in my code. I'd look at it, yeah, I don't see anything wrong either. It must be a bug in the compiler. He goes, what? What? Bug in the compiler? I said, yes. Compilers are written by people just like you. They come down on a Monday morning. They're still yawning, still hungover from the weekend before. They look up at the clock and they see they have 10 minutes to get in their release. It's boom. No testing. Boom. And so you have a compiler that makes, I don't believe it. Okay. We'll make the compiler generate the assembly language, and I'll step through it line by line with you to show you where the error is. And there it was. And then, ooh. But, hey, this is what you do. Don talked about performance. Performance is everything. I'm sorry. There are college professors who will say, oh, because of emulators and simulators, virtual machines, you're so far away from the hardware that performance doesn't mean anything anymore. That's all crap. It's crap. And I'll tell you why. Because on all the virtual machines I know of, when you get to non-privileged code, you're running directly on the hardware anyway. And so all those instructions that are running directly in that hardware, if you can cut out 1 or 2 or 3 machine level instructions in a tight loop, you can get some performance out of it, okay? And only if you're running on an emulator, but you might say, okay, all right, I understand. But no, Performance is everything. Performance is whether you need 10,000 servers in a Google server farm or you only need 9,000. Are you going to need 10 gigawatts of energy or only 9,000? Is your battery going to last you 24 hours or 15 minutes? It's all performance, and performance is critical. I'm not saying that everybody has to study that, but it's a very good market and very lucrative. Now some of you are just studying office, stuff like that. You might ask the question to yourself, should I work for a large company or a small company? I've worked for them all. But a large company is nice. You say, hey, there's a lot of resources, a lot of divisions inside the company. Maybe it's a multinational company. You get a chance to travel and meet other cultures and stuff. I work for DEC. I've been to over 100 countries, most of them more than one time. Some of the countries have a revolving door on the front door to go through. But like Don said, that sometimes your name gets known and you don't have a life. Yeah, okay. I didn't get married till late in life. I haven't raised kids. I haven't experienced that. It's a great feeling. I look at other people. They have a wife and a loving person and stuff, or a husband and a loving person. And I have a husband and he loves me and I love him. And so, I can tell you that the last part of my life has been very good. But large companies can be good. On the other hand, large companies share their resources with many, many, many jobs, many different products. And you may not end up with as many resources as you think, okay? Small companies, on the other hand, they're always trying to scramble for money. They're always trying to make it stretch. They have a lot of stuff to do with their money. But you get a job and you're told you have to do more with less. And you get a lot of experiences in places you might not get experiences with in a large company that puts you into a shoecase here. So take a look at it, make your own judgment as to which way you want to go. Both of them have their advantages. So while I was at Aetna, they funded my master's in computer science. It was one of the first master's degrees given out by RPI out of Troy, New York. I went for 3 years at night, 2 nights a week, and the other nights were spent studying and doing stuff. And once again, I took a compiler course, and once again, it was Aho and Omen. But this time, they took their 2 very expensive books and crammed them together into one very expensive book called the Dragon Book. If you've ever taken compiler theory, I know you know that book, and I know you hate it. But this was the first edition of the Dragon Book, and after they finished it, and I heard this from Aho himself, after they finished it, he said, after that, when we smashed that book together in the first edition, neither Jeffrey nor I could understand what we had written. But nonetheless, it was the Dragon Book, and that's the one you would have to have. Oh my God, it was terrible. I almost flunked that compiler course too. But for graduation, I got to hear Jacques Cousteau. Went up to Troy, New York, went to the graduation, got to hear Jacques Cousteau. That made up for the fact that we wanted to hear Jacques Cousteau at Drexel's graduation in 1973, but we got Spiro Agnew instead. Spiro Agnew talked about honesty and integrity in business and politics. 5 weeks after he talked at our school, he was indicted for income tax evasion and forced to resign from the vice presidency. But I knew at that point that I wanted to teach, and I had my opportunity with my master's degree to teach a small 2-year technical college, much like this one, except we were a lot smaller. We only had about 500 students in the whole school, and we only had 90 freshmen. I'll get that in the next slide. I was elected to be the department head of data processing, but we had a DEC PDP-11 time-sharing system when a lot of the other technical colleges still were using cards and remote job entry. We had a real-time system with a graphics tube, vector graphics tube. We could play Moonlander with it. All the kids loved that. We had a graphics plotter. We had a great school. And we would typically take in 90 freshmen, and we would graduate 28. Now, these students had never even seen a computer terminal. They'd never seen a computer in real life. There were no computers in their high school. There were no computers at their home. when they came into my class and put their hands on that keyboard, that was the first time they ever typed anything into a computer. And we took them from that to being able to write a simple operating system, a simple database, and a simple compiler in 2 years. We beat their ass. And I had students come to me and tell me how much they hated me. And I would say, thank you. I'm doing my job. Yes? Mind me?
Where was that?
Hartford, Connecticut. Hartford State Technical College in Hartford, Connecticut. There were 12 technical colleges in the college system. Unfortunately, a couple years after I left, they combined them with community colleges. And the problem was, they had two different philosophies. The community college was supposed to be the first 2 years of your 4-year degree to get all that stuff out of the way, your French, all things that make you a well-rounded person, you know? And then the technical colleges are supposed to be the last 2 years of your 4-year degree. So if you came to our school and then went to a 4-year degree, you typically only took one more course in your major before you graduated with that 4-year degree. That's what it's, and a lot of our students never went on to a 4-year degree. I had a friend, one of my students contacted me recently and says, I wanted to let you know, I'm a high-level manager at Cisco, and the last time I had any formal education in a class was in your class, 32 years ago. We beat their butts. And I was reassociated with DECUS again, okay, because teaching, I didn't have any money for software and stuff. I get a lot of my courseware and stuff from DECUS. And then I decided to go to Bell Labs because basically I was spending more money than I was earning. And I went to Bell Labs and I interviewed for the Cyber 720 computer system, which was a mainframe of the day. It ran the NOS operating system. Side note, people said that Unix was unfriendly. NOS knew there were users out there and it hated them. And I thought to myself, this sounds like a dead-end job to me because I don't know anybody that uses an NOS operating system on a cyber. So I said, hey, you're Bell Labs, you develop Unix, I know Unix. I also liked having source code for things because I was having source code my whole time. At Aetna, we had source code. We had source code to IBM's main operating systems. They gave us everything because who could possibly put an IBM operating system on another computer except if your name was Gene Amdahl? And so, you know, software, your source code flowed rather quickly if you had the money and power to get it. But I wanted to work at Bell Labs because I wanted to learn Unix. And I wanted to be able to see how Unix was done. I wanted to be able to contribute to Unix. And so I told the people trying to hire me, this is a great strategy for getting hired. It's either Unix or nothing. You know, either you hire me to do the Unix systems administration, but you don't even know Unix. I don't care. I can learn it. Do you have a book? Either I do that or I go back to HSTC. And I went back to HSTC. It took them a week to figure out, okay, we'll hire somebody else to do the NOS thing and we'll bring you in to do the Unix stuff. And I became a systems administrator of Unix without ever having used it before. Now, Bell Labs, Unix was so different than every other operating system I worked on because the hierarchical file system, whereas before I was using flat file systems with maybe a directory to find the files inside of it. You know, this tiny little kernel, which you take a look at the system calls, there's only around 154 of them. That's crazy talk, right? Everything else is the libraries. Take a look at the libraries. Over 10,000 library calls, okay? And you know, this was look at all the bins, /bin, user bin, you know, home bin, etc bin. But when you think about where Unix came from, with the small disk and stuff like that, it made a lot of sense. You're only going to put a very few commands necessary in /root or /bin to be able to get your system to boot and up and so you can mount other file systems. So, wow, this is great. And I could call up people and argue with them about things about Unix. I could get them on the phone. I could argue with hardware vendors. When they came in to sell us more VAXs and stuff like that, I would negotiate for lower prices. I negotiated the price for DEC RAM down from $16,000 a megabyte to $1,000 a megabyte. I negotiated disk drive prices from $32,000 for a washing machine sized disk to like, I think it was like $18,000 for two. I was a good negotiator. And my job at Bell Labs was to do better and faster and cheaper. And once again, I was exposed and drawn into DECUS and also this other organization called Unix, which specialize in, the charter is actually modern operating systems, but at that time, that was Unix. And Uniform was a commercial version of that. So I worked there for about 3.5 years. I had 4 people reporting to me. And then DEC called and said, we're starting up our own Unix group. We're going to be creating our own version of Unix. Up until that time, they have been supporting hardware support for AT&T Unix, System 5, System 3, System 4, System 5, and for Berkeley Unix. And they said, we want to bring out our own Unix system, and so we're building up our engineering group to do that. And so I started working with them to bring out their own Unix-like versions. I say Unix-like because to say the word you are Unix, you have to pass the X-Open test suites, and you have to pay money to Open Group to license the term Unix. So every Unix system is actually Unix-like, except for Apple. The last time I looked, Apple OS is actually Unix. They actually have a brand that they can use. But while I was there at Digital, I became known as a good fairy of Unix, of Digital's Unix box, not because I'm gay, but because I would make things happen, particularly for customers, because I knew what it was like not to have the source code, not to be able to write your own device drivers, not to be able to fix little problems. I knew what it was like. And so I had a magic wand, and I would wave it, okay? And I gave Richard Stallman his first VAX computer system with Ultrix on it so he could port the GNU tools to Ultrix. That was 1986. I convinced management to take those tools and pre-compile them onto our systems and give them away pre-compiled, saving all of our users the whole time of doing that. That only took 3 engineers part-time. That's a ridiculously small number of people. But the customers loved that, okay? I convinced the ISO 9660 editor to take the original ISO 9660 specifications for CD-ROMs and ISOs of all types that originally could only have 4 directory levels, 8 letters in the character name, and a 3-character extension. That's what the spec said. And I was called up by somebody from a company called Young Minds, who had what is known as a Rockridge extensions that would allow Unix and later on Linux systems to be able to have a file system that could be read and written to. And he says, I've been having problems getting the editor of the standard to accept these. Can you help me? I says, I don't know. What's his name? Walter. I says, Walter? Walter has a cubicle about 3 cubicles away from me. I know Walter very well. And Walter has the same senior VP I do. So I went over to Walter's desk and I said, hi, Walter. Walter's working away. Hi, Mad Dog. What's up? Walter, you're going to put in the Rockridge extensions to the ISO and submit it. He said, no, it's not enough time. We haven't tested enough. Walter, either you do that, or I go to your senior VP and tell him that you're syncing our Unix distribution, not going on to CDs. Do you want me to do that, Walter? Damn you, Mad Dog. And it went in, and it worked perfectly. From that, I was able to force the distribution of our code off of magnetic tape, which would cost $100 a tape. There were 3 tapes in the distribution, put it all on 1 CD, which in the end was $1.25. We still charged $1,500 for the distribution, but we made a hell of a lot of money. And then I had a vice president who said you could only have one person at a time logging into a workstation. I said, well, a workstation, I mean, Sun is allowing like dozens of people to log in. One person's using the graphic tube, everybody's coming in through the network. No, 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 only one person doing that. I says, well, okay. But then I started writing white papers and distributing it and getting support of management and stuff. And I held this big meeting, and the senior VP showed up and said, well, I only meant that for VMS workstations, not Unix workstations. Boom! We had multiple Unix workstations. Now, you'll look at Microsoft, and they will say today, the Microsoft Windows will allow you a multi-user system. But read it very carefully. What that means is one person at a time logging in, but you could have 5 or 10 or 15 people using the same system, but not simultaneously. Versus Linux, you can have lots of people using it simultaneously, even with graphical workstations, graphical terminals. And I worked again with the DICAS Unisig. Unisig stands for Unix Special Interest Group inside of DICAS. And they were run by volunteers, they were run by customers, not deck marketing people, but they would invite any Unix people to a DICAS meeting, to a DICAS show, and we had 19,000 people show up to DICAS twice a year for events. And there were always customers helping other customers, hallway conversations, hallway symposiums, we said. Do not be afraid to stand up and ask questions of anybody else at DICAS, because they would always help you out, okay? So I went to DICAS New Orleans in May of 1994, and Kurt Riesler, who is the head of the DICAS Unisig, said to me, you haven't heard about this guy, you haven't heard about this software, but I want to bring him from Europe to DICAS, and I need $5,000 to do it. So I took Kurt's letter, and I wrote to my management and said, I don't know who this guy is, I don't know what he did, but Kurt sometimes has good ideas, I think we should bring him to DICAS. My management went to their management and said, we don't know who this guy is, we don't even know who Kurt is, but maddog sometimes has good ideas, I think we should bring him to DICAS. And so, in DICAS of May of 1994, I saw Linux for the first time running on a weak, miserable, crappy Intel PC. Because I made real workstations. I made VAX workstations, MIPS workstations, Alpha workstations, real workstations, and this was running on a weak, miserable, crappy Intel PC. But when I sat down to it, I started to use it. Now, how many of you play the piano? You know that any good tuned piano could make reasonable music, but if you play something like a Baldwin or something that's a really good piano and all the keys are perfectly weighted and all the equal stuff, that it's a joy to play. And that's what this was, even on that weak, miserable, crappy Intel PC. If I thought of it as System 5, it was System 5. If I thought of it as Berkeley, it was Berkeley. And I said to myself, this is fantastic. And then I went to hear the talks, 2 talks that Linus gave. Out of the 19,600 people there, only 40 people showed up for each one of the talks. 2 years later, at Linux World, 6,000 people showed up at this talk, filled the room, and went to overflow. But at this time, only 40 people. And so I took Linus out on the Natchez riverboat. We were going up and down the river, drinking these wonderful drinks called hurricanes, made with rum. And I said, Linus, have you ever thought about taking Linux, running on that weak, miserable 32-bit Intel system, and putting it to a RISC Alpha 64-bit system? He says, well, I thought about doing that, but DEC Helsinki's been having problems in getting me one, so I may have to do the IBM PowerPC instead. What? And I dropped my drink. And everybody knows I don't drop a drink, okay? I said, don't do anything rash. I went back to my office in New Hampshire the next day, and I called up my friend, Jim Jackson. Now, people will tell you the way you get things done in a large company is you write a proposal, you give it to your management, they mull it over, they hand it to their management, you get some funding, da 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 da. That's all crap. What you do is you pull in favors. And by that time, I worked for DEC for 16 years, and I had done a lot of favors. And so I called up Jim. I said, Jim, I need to have an alpha system sent to Helsinki, Finland right away. You don't know who this guy is. You don't know what the software is. You know, I just need to have it done tomorrow, Jim. And he's laughing at this point on the phone. He says, well, I just so happen to have a seed unit that's underneath my desk. Now remember, this is 1994. 21-inch color monitor, Diamond 3D card, you know, DEC Alpha system with 96 megabytes of main memory, a 4 gigabyte hard drive, a CD-ROM that's 2x, okay, and, you know, keyboard, mouse, monitor, stuff like that. And this system would cost about $30,000. And I said, Jim, great system, but you have to toss in a 4mm tape drive, another 6K, because he needs to be able to do backups. Okay. What are you going to pay for? I'll pay for the shipping. And the next day, that system was headed towards Helsinki, Finland. So then, I started to assemble an engineering group inside of Digital, mostly in the semiconductor division, because they wanted to sell more alphas, to help with some of the low-level stuff to put Linux on the alpha. And starting on January the 1st of 1995, because Linus had to finish up the second edition of Linux to stabilize this stuff, we started the port, and in September of 1995, it was done. Taking something from a 32-bit system to a 64-bit system, completely different architecture. And when Linus set up the tree, he didn't set up for 2 architectures, he set it up for N architectures. And that's when I knew I was dealing with a smart guy. And also remember, I had no authority to do all this, any of this. I had no budget, I had no people working underneath of me. It was all because I had favors that I was pulling in. And so that was when I started selling free software. My mother kept asking me year after year, what do you do for a living? Well, I do software, Mom. I don't understand that. She finally got a computer system, and after she used it for a little while, she said, okay, John, now I know what you do. You write the programs that I use in the computer. Well, Ma, I haven't done that for like 10 years. Now I sell free software. Never mind. So here I am, I'm trying to sell DEC Unix, and we were selling it for like, $10,000 a copy or so, but I was also pushing Alpha Linux to get it out the door. And I could prove to my management that I could sell more digital Unix by doing the Alpha Linux project than without it. And I did. And because Linux Alpha was great, it was fast, you had all the source code, stuff like this, but digital Unix was a stellar operating system back when Linux was single core, single CPU, not multi-threaded, stuff like that. Didn't have a robust file system. We had all that stuff in digital Unix. So people would try out the alpha with Alpha Linux, find out that Linux just didn't quite meet their needs in a lot of cases, and then they would start using digital Unix. But Linux, as Don said, made a lot of sense to a lot of people, because you could use Linux to set up your own DNS server, your own firewall. You could reuse hardware that was now too slow to run Microsoft anymore, but ran exceedingly well with Linux. And that forced the Linux market to grow. At the same time, a bunch of us got together and said, we think that Linux has a future as a business operating system. Sure, it got to start as a hobbyist operating system, as a technocrat operating system and stuff, but we could see where this is going to have huge value as business. So we started Linux International to train people to be Linux systems administrators, to give certifications to people who wanted to be Linux systems administrators for banks, insurance companies, for places that could barely say the word Linux. So you would know that you had somebody standing in front of you that could handle the job. So here's the lessons I've learned. I've learned a lot more, but these are some good ones. Work at what you love. Because you're going to be putting at least 8 hours a day, 50 weeks a year into it, and probably a lot more. And if you don't love it, it's going to be torture. But if you do love it, it's fun. Oh, it's fun. The worst thing in my life is to be bored. I can't stand being bored. And I can honestly say there's never been a day in my life since I started programming that I've been bored. Learn everything. I mean, I know that some of you are going to these schools, you say, man, they're teaching me these courses. I will never, ever, ever use this stuff. Wrong. You will. There's not a single course I ever took at Drexel or anywhere along the way that I haven't used. And by the time you need it, it's too late in a lot of cases to learn it, okay? But you have to also say to keep learning, because if you stop learning, you move backwards. So one thing that universities teach you, they're not here to teach you a job. They're not here to teach you how to work. They're here to teach you how to learn on your own, okay? How to go to books, how to go to the internet, how to learn on your own, and how to differentiate the truth from the untruth. It's easier to love than to hate. It's easier to smile than to frown. I actually learned this late in my working life because I have the name Mad Dog. I earned the name Mad Dog. You don't see this. You see a smiling old man with white hair and a face who goes ho, ho, ho and gives away free software. But inside of me, there is a seething, angry person who one time was told by a manager, Mad Dog, if you continue this way, nobody's going to work with you, and you'll be limited in your value to the company. And that day, I changed. Everybody is interesting in their own way. No matter how tiny the life you think, you start to look into it, they have an interest. And it's easier to work with each other than against each other. Don brought that up again with collaboration. And don't be afraid to do what you need to do. The other day, last night, I was told that there were some people while we were out having dinner and stuff, they were afraid to come up to me and talk to me because they might interrupt whatever I was doing. And quite frankly, there was nothing more important of what I was doing than to talk to them. So I would go to Unix meetings and Unix meetings. There would be Dennis Ritchie, co-inventor of Unix, inventor of the language C, and a bunch of other stuff, standing in the corner with a glass of white wine, and nobody was talking to him because they were afraid to talk to the great Dennis Ritchie. And yet Dennis was the nicest guy to face the earth, and he would talk to anybody about anything. So do not say, no, I'm not gonna, no. I don't do this to anybody. You shouldn't do it to anybody either. And then finally, it's easier to ask forgiveness than permission. The great Rear Admiral Grace Murray Hopper said that with a bunch of other stuff. If you've never seen or read about her, please do. She is a legend in computer science. So with that, I don't know if we have any time left. 15:24. We have a couple more minutes before the auction starts. We have to get over the auction because but I'll be around a little bit. Come and talk, please. Thank you very much.